The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, welcome to our webinar. Today's webinar is about how to maximize revenues on your customer loyalty program using predictive analytics. So, before we begin, let me give you some of the usual tips. Please make sure that your mic is muted and that you are able to listen properly. Also make sure that you are able to view our screen being shared with you. We will be providing the recording of the webinar, model code, data, and the script soon after the completion. If you have any questions during the course of the webinar, please send them via the chat window or tweet at Tatvik. After the webinar, you will be redirected to a survey. Your feedback would help us improve our future content, so please do complete the survey. A small introduction about your speakers for the session. Hello everybody, I'm your host for the today. My name is Shachi Parekh and I'm a technical analyst at Tatvik. We have with us Kushan Shah, who is one of our resident web analysts. He loves analyzing data for gathering insights. His favorite tools include R and Pandas. As you might very well know, we are here to talk about how customer loyalty programs can be directed more effectively. So, we will commence with a brief background and motivation for the customer loyalty. This will give us the necessary intuition to define the business problems for the predictive analytics. We will then digress into a short refresher to predictive analytics. Once that is done, we will define the data sources and the variables for the problem. Then, Kushan would explain the core algorithm and walk you through the model implementation steps in the R programming environment. So Kushan, thank you for being the part of the webinar. Can you give us a brief idea about customer loyalty and why are we focusing on this problem today?
Sure. Thank you, Shachi. It's my pleasure to be here. And let's begin. The problem of customer retention is not a very new problem as such, but it has gained a lot of importance lately due to the rising cost of customer acquisition. So I would say that although a lot of new customer acquisition channels have opened up for e-commerce stores, for example, email marketing has been a very email marketing has seen a very recent surge in its utilization for customer acquisition across a lot of e-commerce stores. There are always the classical channels like paid search, organic search has also been a very key driver. But the common idea behind all these customer channels is that the cost per acquisition per customer is indeed very high. So I would say retailers who are looking to improve their business's bottom line are they would be more of focusing their efforts and channeling their marketing efforts towards keeping or retaining customers as such. This is because there are three main merits behind customer retention. One of them is that repeat customers tend to create higher order value, higher economic value, both in terms of the average order value as well as the total revenue that they contribute to your e-commerce store. Repeat customers also tend to engage in word of mouth. Thereby, this becomes this leads to a domino effect and helps you acquire more customers. Then the cost of sending a targeted campaign to a repeat customer group is always less than hiring, let's say, a SEO or a PPC expert. So these are the merits behind having repeat customers, and this is in general the idea about customer retention.
Interesting point you mentioned there, Kushan. Okay, repeat customers create higher economic value. But is this any hypothesis or do you have any data to back up your claim?
Yes, I would like to expand on this point, repeat customers creating higher value in terms of average order value and revenue. And for this, I actually pulled up a bunch of Google Analytics e-commerce data for a sample size of 500 consumers. Mind you, this is actual data, and this shows that this shows actually the proportion of transactions for one-time versus repeat customers. So what we can see directly here is that 85% of the total transactions in a given time frame happened due to the one-time consumers cohort versus just 15% were attributed to the repeat customers.
All right. But how does this affect the bottom line of an e-commerce store?
Yes. In terms of bottom line, I wanted to include one more metric rather apart from the proportion of transactions, because this is a fairly common occurrence across in general across a large number of e-commerce stores. One-time consumers always tend to be higher in proportion in terms of transactions. So the next metric I wanted to look at was the revenue contribution due to both these groups. So I have adjacent to the contribution to total transactions, I have plotted the contribution to total revenue. And what we can see here is that no doubt one-time customers have contributed to 60% of the total revenue. That is a very, very good number. But if you see in this right-hand side portion over here, 15%, that was the statistic earlier, and that particular group of customers contributed to 40% of the total revenue. Now, if I were to sum up this point, 15% of 5,000 is 750, and 750 repeat customers driving 40% of the total revenue, that is huge.
I see. So Kushan, what conclusion do we derive from this data?
Yes, before I answer that question, I just wanted to expand a bit upon this particular number. Why this number is high? It might be because these customers might be buying more frequently, or they might be buying higher value items per order. So I think I have driven home the point that repeat customers are indeed valuable to your e-commerce store. And now coming back to your point, the key focus or the key implication for e-commerce marketers would be to shift a portion of this group of one-time consumers to becoming repeat buyers. Now, there are a couple of ways to do this. One of the ways is to engage in customer loyalty programs. The other way would be to engage in customer service or build up a unique differentiator that sets your e-commerce store apart from the other ones. So in the next slide, as a hypothesis, even if we were able to convert 5% of this particular group into to, let's say, fall into this bucket, then that would be a key or a very good improvement in bottom line. Was I able to answer your question, Shaji?
Absolutely, it does. Now that we have understood the motivation of customer loyalty, what do you think is a good approach towards ensuring that this happens?
Sure. As I mentioned earlier, one of the popular approaches followed by e-commerce marketers is to provide an incentive to customers to carry out a repeat purchase. So discount coupons are really a very go-to mechanism for ensuring that this happens. Discount coupons have to be sent at the appropriate time. Now, the downside of sending out discount coupons to all these one-time customers is that since this discount campaign is non-targeted, it might actually suffer from a low conversion rate. And the other aspect of this is that since a large number of customers are influenced or to purchase on account of this discount coupons, it does make a dent in your sales margin. So there is indeed some revenue loss involved in this campaign, and I wanted to discuss this point in a bit more depth. Assuming that let us say the size of a typical email prospect list is 100,000, and we are sending out discount coupons to all these email prospects, and assuming that this 5% of those people or customers, I might say, land onto your website, then with a standard with a generic e-commerce conversion rate of 2.5%, that would lead to 125 transactions occurring on your property. Again, this is just an assumption, and with an average order value of $250, if you provided a 20% discount, then the dollar value of discount per customer or per transaction would be $50. Now we come to the actual interesting part here. If let us say this 125 group of people, they are divided into two parts. There might be a section of customers who made a purchase only after a discount coupon was provided, assuming that is 60% of 125, assuming that is 75, and there are those customers who would have bought anyway, maybe at a later time, but they might have bought even without a discount coupon. That is 50. So the loss in, I must say this is a mistake on my part, it's margin actually. The loss involved due to these 50 customers buying under the effect of discounts is 50 multiplied by the dollar value per customer, which is $50. That would be $2,500. So if you were to send this entire campaign 4 times a month, then that stacks up to what, $10,000. So there is indeed some revenue loss attributed to this particular discount campaign. And so this leads us to this matrix by Dr. Eric Siegel. Dr. Eric Siegel is an author of a very famous book on predictive analytics, and he is a very successful practitioner, been in this field for quite a long time, and he has summed this particular effect very well in one of his blog posts. So we are not focusing on these both segments of customers for the present moment. What happens is we saw two classes, sure things, and we saw the persuadables. The sure things were those customers who would have bought irrespective of a discount, while the persuadables are the one who had to be targeted, and they would be influenced with a discount coupon. So the implication for marketers again is that if we were to target our discount campaign only to do this particular group over here, then that would definitely fix up the revenue leakage which I mentioned earlier. So the key point that I'm trying to drive home is that we wouldn't direct our loyalty program to all these customers, just this group over here. Of course, this would require us to segment or find the delineation between this segment here and this segment here. And the focus of today's webinar is on using predictive analytics to segment customers on some key characteristics. So with this entire picture in mind, we come to the actual business question. Having a business question gives us a clear-cut goal and a clear-cut next steps as to how to proceed with our problem. So we want to predict customers who would make a repeat purchase within 2 months of their initial purchase. So the outcome variable or the response variable in our case is that is whether the customer would make a repeat purchase within 60 days or not. This might be in form of a probability. This might be in form of two labels, either yes or no. And we want to answer this question using data of past customers who have already made purchases on the e-commerce website. So
Great.
yeah, that's it.
Sorry.
Please carry on.
Now that we have the question framed well, what are the prerequisites to answer that?
Sure. So let me just summarize a bit for the previous 10 slides, and then I'll jump to the answer for your question. So we saw that repeat customers are valuable, and we definitely need more of them. So the key idea of converting one-time customers to repeat customers is sending out discount coupons. But if we do this without segmentation, there is a loss in revenue. And we are trying to use a predictive model to find out those customers who would have not made a return purchase without a discount coupon. And once we have the list of such customers, we'll be targeting our discount campaign or discount coupon only to this segment. And now to answer the question, having just the question in mind is a good first step. We would require actual concrete data to answer that question, and the data which we'll be using, or the data sources which we'll be using in our case, would be Google Analytics, and the next would be CRM. So Google Analytics would tell us that for a particular, what was the date of transaction, what was the product category bought by a particular customer, how many items did he purchase, whether a shipping cost was incurred in the transaction or not, and a very important variable which I seem to think of it is what was the medium through which the customer was acquired on this particular website. And CRM data, CRM might contain additional attributes such as whether the customer has been a subscriber for the newsletter, did the customer make the first purchase after redeeming a discount coupon, when was the account creation event for that particular customer.
Now that I see that we have the data ready, I think we need a way to connect both these data sets, right?
Yes, exactly. Both these data sets have to be connected via a unique customer ID. And in Google Analytics, this customer ID can be fetched after customization. And the same customer ID has to be pushed into the CRM during the data collection stage. And let me show how the data looks like in Excel. Here is the data. I'll just zoom in a bit, and okay, so this is the customer ID that I just talked about. The transaction date, medium, I have encoded it as a category. Every unique number represents a particular medium. Item quantity is again a numeric variable, and this item quantity, I have broken it down into categories. There are actually, if you see, there are 10 unique categories, and these both numbers add up to this item quantity over here. So, and this is the variable which we are interested in, the outcome or the response variable that I just talked about. Repurchase underscore 60 it tells us whether the customer came back or not, and that is encoded as 0 or 1. Shaji?
Okay, got that. Can you shed some light on the tool we are planning to use?
Sure. We'll be using R to build the predictive model. R is a very great tool for this purpose. Now it might sound R might be intimidating to people who don't have a previous experience in programming or in coding, but trust me, R is a really is a tool worth learning, especially for data analysis and predictive modeling. So we have covered R in 2 of our previous webinars, and we also have a lot of blog posts devoted to R. So, if you are not familiar, sorry.
No, continue.
So if you're not familiar with R, I suggest to look, just have a look at that.
R seems interesting, but one of the questions that I see a lot of people asking is, how do you get Google Analytics data into R?
Yes, I saw that question. I saw that question was a recurring question across some of the queries that we got. So let me digress a bit and see how we could extract Google Analytics data into R, and then we'll come back to our we'll continue our discussion on predictive modeling. So assume that this is us. We are trying to extract data from our particular from our Google Analytics account, and we will be using the API. The API is just a gateway that gives is guarding the data or Google Analytics data. And the first step is authentication. We need to authenticate ourselves. This is done by passing an access token request and to the Google server. The Google server in return gives us a response, and now this completes the authentication. The next step is to ask or to retrieve a list of profiles belonging to our Google Analytics account. And once we have the list of profiles, we select the profile ID that we wish to query, and with that we pass a list of dimensions, metrics, and the time frame for which we want to query our data. Now I know this sounds this entire image sounds very scary, but I am trying to build a mental model or a mental image of what the R code is actually doing in the backend, so that people might gain a more intuition into the data extraction step. And with that, I'll jump on to R and let us extract some data. Sorry. So this is what R looks like. This is where we write our code, and this portion over here gives us outputs. So R has this concept of libraries. Libraries are add-on packages that are used to explore additional functionality that is not contained within R or within the base version of R as such. So R Google Analytics is a library which helps us to extract data or Google Analytics data, as I mentioned. So we'll load that library into memory, and then we will be authenticating ourselves. This will of course redirect us to the browser where it is asking us for offline access to our profile. Then this is where the access tokens come into picture. Here I am doing the exchange for access tokens, and this is the one that this is the one that the API has returned. So what I'll do is I'll copy it, and R is telling me to paste the access token here so that it can remember, and voila. So that is where the access token comes. So with that, we get the list of profiles associated with our account. It might take a while, especially if your account has a huge number of profiles. In our case, there are 340 profiles, and we'll just see what this looks like. So there are a lot of profiles here. We are interested in this particular profile, and we need to get the row number corresponding to that, and this is where we are typing it. So now, as I mentioned, we select a particular time frame, start date, end date, and dimensions and metrics which we require let us say for this particular problem, we are extracting transaction date, custom var value 5 is the customer ID, medium, product category, item quantity, and this is how we build the query. The dimension and metric names are very similar to the analytics user interface, but we just need to prefix them with GA colon. And this query is ready. So let us fire the query. The API was very fast. It has returned us 1,000 results within a span of a second. And let us see what those look like. There we have. So that was the data extraction step. Now in our case, what we can do is we can, if you want to look at these results later on, then we might just save this particular table offline using this write.csv command, and there it goes. Here this gets saved. So even in for this particular problem, I have performed the data extraction, and I have also done a bit of manipulation with the data so that it looks like the one shown here, and I'll just load it into memory. So there are two data sets, e-commerce data, and there is also CRM data, which contains the CRM variables. So there it goes. CRM data is ready, e-commerce data is also ready. So that concludes the data extraction portion.
Now that we understood the data sources, what is next on the plate?
I think it would, we resume our discussion on predictive modeling. And before I jump into the nitty-gritties and the intricacies of what a predictive model is and how we could implement it in R, I think let me take just 2 minutes and try to develop a bit of intuition into what happens behind the scenes inside a predictive model. So assume that a kindergarten teacher is trying to teach a child to distinguish between images of a bike and that of a house. So initially what the teacher might do is the teacher might show actual images to the child. The child learns to identify that the image of a bike contains round edges, while that of a house contains square and rectangular edges. So for the child, this is the learning stage where the child learns to develop a sort of mental picture into what both these images look like. And next, when after this entire training or learning step is over, the child has learned to classify. And when we show the child a new image or an unseen image, then the child might have accurately learned to classify or learn to distinguish between both these sets of images. So I want to just emphasize the point that this is the exact intuition behind supervised learning. Why is it called supervised is because the child was being supervised on the basis of actual data being shown to the child prior to the learning stage. So let us, with that example in mind, let us map this concept to actually what we are trying to achieve. So this you can say is the training data. Let's say the images of the actual images shown to the child in the learning stage. These are variables. Variables might be whether the image has round edges, whether the image has square edges. Labels are right answers. Right answers might be this particular image is a bike, the second image is that of a car. These three things are fed into a particular machine learning algorithm, and what happens next is when new or unseen data is shown to this particular child, then because this model has been already developed, the child learns to predict answers, right answers for the unseen or for the test data. So then let us with this picture, I'll just focus a bit on what the algorithm we are planning to use for this particular problem, and it is called logistic regression. Now I am intentionally not going into the mathematical details of what logistic regression is, because that would not seem very interesting to the audience. I'm focusing on what the model does. So since in our case the problem is to classify whether customers carried out a repeat purchase or did not carry out a repeat purchase, logistic regression seems to be a good starting point to classify our data in each of these two cases. And once this model is ready, our next step would be to see how the model is performing on unseen data and calculate the accuracy metric. So how we do that is we split the data randomly into train and test, because we have a lot of data. We just saw we had 32,000 records, and we'll fit a particular model. This model is called the model is logistic regression. As such, it is just known by a slightly different name in R. It's called GLM, where GLM stands for generalized linear model. And once we fit the model on the train data, that is this orange segment, we then run the model on test data and we predict outcomes for the test data. So I will then jump to R and implement the steps that I just showed in the slides previously. So this requires us again to load load some other libraries. So we just saw that e-commerce data actually contains a customer ID column. This is where it is, and even the CRM data that too contains the same customer IDs. So we need to perform a VLOOKUP or a join between both these data sets, and this is done via the join function. R will come to know that a customer ID is the same is a unique column between both of them, and it will tell us that it has already accurately learned to join both of them. This is a data preparation step. Now, because what happens is there are a lot of discrete data types inside our data set. For example, transaction date is a date variable. Medium is belongs to a category. Each medium is a separate category. It's just encoded as a number for privacy purposes. Item quantity is a numeric variable. So we need to tell R explicitly to consider some variables as categories and the rest of the ones as numeric variables, and dates as well. So we'll convert the transaction date and the account creation date to date variables. This is done via the YMD function. Once that is done, the rest of the categorical variables have to be encoded as factors. Factors is a term used in R to denote categorical variables. So all these variables have to be converted into factors. And finally, the outcome variable for us, it contains 0 and 1. 0 is a class of customers who did not make a repeat purchase within 60 days. 1 is the other way around. And this is also category. It's a binary variable as such, denoting two categories. So that also needs to be converted. So with that being successfully accomplished, we'll have a look again at whether it happened correctly or not. So this has been correctly done. Factor, again, dates are correctly encoded. Now if you see, customer ID as such, it does not have any predictive power or any merit to the predictive model. So we might be better off removing customer ID column. Since now the join step is over, let us remove customer ID And for the time being, I'll remove the date columns as well. I'll justify why I did this, why I removed the date columns in a few minutes. And these all are stored within a particular list, and I'll just remove all these 3 columns from the data frame. And now we need to partition our data into train and test. The ratio, as I mentioned, between train and test is 80%, which is denoted as 0.8. And this is the function which we'll be using for creating the data partition. So once we have this variable split, we can now subset our data on the basis of split, and the labels which belong to split, I'll keep it into train. The labels which do not belong to split, I'll just remove them off and keep them into test. So we now have 2 data sets. Train data contains 25,943 records. Test data contains 6,485 records. So we now come to the actual modeling stage. GLM, as I mentioned earlier, was the function used to create the logistic regression model, and we need to tell this function that this is the response variable that we're trying to predict, and dot means that consider this response variable is a function of all the rest of the variables in the data frame which are belonging to this particular data set here. So we create a particular we created the logistic regression model, and once that is done, we want to check which are the influencing variables in the fitted model, or which are the important variables. So this is done by the summary command. I'll just zoom in to see how this works. So if you have a bit of background into statistics, these are the p values for each and every variable that we had inside the trained data set. So what this means is that lower p values mean that that variable has a higher influence in predicting the outcome. So if you see, the p value here for item quantity is 10⁻⁻⁵. So that might lead us to believe that a customer ID with a higher item with a higher number of with a higher value of item quantity, they might have a higher probability of returning. Customer IDs who have bought items within this particular category, category 1, they are interesting. Again, customer IDs who have subscribed to the newsletter previously, they also have a higher probability of coming back. Apart from that, people or customers who incurred shipping cost, they also have a higher probability of being repeat purchasers. So that leads us to the next step, where we are trying to check or trying to derive accuracy metric for this particular model that we carried out. So if you see, for let me just open up the test data frame. So if you see here, where was it? Here. Test data already contains some answers. These are the right answers. This came in because we already had them prior to loading the data itself, and these are the actual labels or right answers. I will store them separately for the moment, and what I'll do is I will use this model to predict answers for this test data over here, and this will return probabilities on a scale of 0 to 1, and I'll just round them off to convert them into zeros and ones. So with that being done, we now create a confusion matrix, and I will explain what a confusion matrix is with the help of a slide. Let us just create it for now. So this is what a confusion matrix looks like. References are the actual outputs. 0 and 1 are the two classes which we are trying to predict. These are the predicted outputs, and if you see here, the accuracy comes out to be 81.3%. And let us see how this figure is being derived inside R. So I just copied the confusion matrix from R itself, and if you see here, actual labels are the right answers for the test data frame. They were contrasting them with the predicted labels. We got them by running the model on the test data set. Now, the interesting out of this grid of 4, 2 versus 2, the interesting ones would be where our model agrees with the actual labels. So if you see here, when in this case is 500 to 5271, the model also returned 0, and the actual labels were also 0. In this grid, in this cell over here, the model returned 1, and the actual label was also 1. So accuracy is calculated as follows. It is the sum of correctly predicted labels, 5271 plus 1, divided by the total number of records that we had. And this is how we got the figure 81.3%. Now, for a basic version of the model, this figure is reasonably good. There are ways to improve this, and let us see how it can be done. We could add new features to the model. Remember, we discarded the date variables. We could actually take the difference of both these dates, account creation date and the first transaction date. So what would it mean is that, let's say if a customer created an account on the site 2 days back, and he comes today to make the first purchase, then that might lead, because the difference is the time frame is very short, that might actually lead the customer to return and make a further purchase within 2 months. We could also check if the transactions had occurred during the weekend based on this transaction date over here. We could directly add a couple of other metrics from Google Analytics. Days to transaction might be a good interesting metric to see if it works. Device type, either a tablet or a mobile or a cell phone from which the transaction had occurred. So apart from this, we could try out other models like random forest, gradient boosting, or support vector machines. But all these 3 over here require some additional training in statistics and a bit of programming know-how into R. So that concludes my part. Shachi, can I go forward?
Thank you, Kushan. That was really helpful. I hope the audience enjoyed it as well. Now I think we have a couple of questions. Here comes the first one. How trustworthy is the model accuracy metric?
Yes, that is an interesting question. In this case, what we did is we just made just one split into 80 and 20. What we could do in another or in a different version is that we could make 5 different splits, 1, 2, 3, 4, and 5, and perform repeated training testing. This entire process is called cross validation, and that makes the model more generalizable and more amenable to incoming or unseen data. So cross validation would be a very good way to check the trustworthiness of the model accuracy metric. But for a starting case, even testing on a singular particular static instance of just the test data is a good way to go.
Okay, we have one more question. How do you get CRM data into R?
Well, I must admit that I am not too sure if there are wrappers or libraries in R specifically devoted to importing CRM data directly. In my case, what I did is that the CRM had a functionality where I could export the CRM data in the form of a CSV file, and then I imported that CSV file directly into R. but I would definitely want to research into this particular question and maybe provide the answer at some later point.
Okay, thank you. Due to time limitations, we will not be able to answer all your questions. But don't worry, we will get back to you via email. I guess that sums up well. Thank you, Krishan. We would also like to update you about our upcoming webinar, How to Perform Churn Analysis for your mobile application, scheduled at March 18th, 11 a.m. PDT. Please register.